Okay, I'm going to just try and do this question for you, Sophie. So hopefully this will make it a little bit clearer. So Erin leaves home at 11 a.m. She cycles for at a speed of 16 miles per hour for 90 minutes. She stops for half an hour. Erin then cycles home and arrives at 3 p.m. Draw a distance time graph to show Erin's journey. What is Erin's average speed on the return part of her cycle? Okay, so what we'll try and do is just get a rough picture of what's going on. So she leaves at 11 a.m. She then cycles at a speed of 16 miles per hour for 90 minutes. So we're going to have to work out what distance she travels there. Let's just have a think about that. So she's going, let's go over here, she's going 16 miles per hour for 90 minutes. Now, 90 minutes is 1.5 hours. So using our speed distance time, speed equals distance over time, which means if we're trying to work out the distance, which we're trying to do here, we're going to do speed times time. So distance travelled during this time is equal to 16 times 1.5. 16 times 1.5 turns out to be 24, so we're talking about miles. So she goes 24 miles. Right, let's try and put this in a graph then. Now, forgive me because I'm going to need to draw my graph without using a ruler. Okay, so she goes 24 miles, she stops for half an hour and then she comes back at 3. Okay, so let's just try and use a suitable scale. So if we draw a line here. Now actually this graph it doesn't really matter too much about this axis. I just need to make sure it goes up to 24, the distance away from her home. So 24, I'm just going up in sixes on that, so 6, 12, 18. And this is distance from home. And then time along the bottom. And she starts off at 11 a.m. and let's just go one by one, shall we? So 12, actually, we're talking about half hours, aren't we? So rather than making that 12, let's make that 12. 13, 14, we're going 24-hour clock. She gets back at 3, so she gets back at 3:15 o'clock. So what does the graph look like? So she travels 16 miles per hour for 1.5 hours. So 1.5 hours is there, and during that time we've just worked out that she travels 24 miles. So you've got a straight line graph like that. She then stops for half an hour. So there we go, stopping for half an hour. Distance isn't changing, and then she comes back home to arrive back at 3. So something like that. Again, sorry, I should have a ruler, but I can't hold my phone and a ruler at the same time, unfortunately. Okay, right, so what do we do then? The second part of the question says, what is Erin's average speed on the return part of her journey? So during the return part of her journey, obviously she's still going 24 kilometres back home. So she was 24 kilometres away there, she's back home here, 0 kilometres away. So she's travelling 24 kilometres, but she's only doing it this time it's in 2 hours. So fairly straightforward. Her speed, again, if we go back to here, so speed equals distance over time. So her speed, her average speed for part B, is going to be 24 distance divided by time, which is 2 hours, which is 12 miles per hour. Okay, hope that helps a little bit. So, I mean, the questions do, I think, get a little bit more complicated, don't they? But just try and get a rough picture of what's going on. You're going to need to do some of these calculations, obviously, to complete the picture. Hope that helps a little bit for you to have a go at questions 2 and 3. Okay, thanks.